Hello trigonometry students! This video is going to start our discussion for Chapter 2. My name is Jamie Amy, and here we go. Title of Chapter 2 is Acute Angles and Right Triangles. We're going to start with a statement. Cofunction values of complementary angles are equal. There are a lot of terms in that statement. Let's read it again. Cofunction values of complementary angles are equal. Let's break that down. First of all, cofunction values. Well, which functions are cofunctions? And the answer is there are three pairs. Sine and cosine are a pair of cofunctions. Tangent and cotangent are a pair of cofunctions. And the third pair is secant and cosecant. They are a pair of cofunctions. So our statement says that cofunction values of complementary angles. So our next question is, well, which angles are complementary? And complementary, if you recall, it means angles that sum to 90 degrees. So using this triangle right here, we have three angles, capital A, capital B, and capital C. Which two are complementary? Answer is A and B. Reason? Triangle angle sum theorem says that all of the interior angles of a triangle have to sum to 180 degrees. And if this angle C right here is taking up 90 of the degrees, then the remaining degrees go to A and B, which must sum to 90 degrees. All right, what does all of this lead us to? Cofunction values of complementary angles are equal. What that leads us to looks like this. Sine of angle A, its value is going to be equivalent to cosine of angle B. The value of tangent A is equivalent to the value of cotangent of B. And third one, the value of cosecant of angle A is equivalent to the value of secant of angle B. Make sure that you have cofunctions paired up correctly. So sine paired with cosine, check. And you have to make sure that your angles are complementary, so A and B. So these three identities hold. Completing this statement, cofunction values of complementary angles are equal. Exercises addressing this will look like this. Write each function in terms of its cofunction. Sine of 45 degrees. Sine of 45 degrees has a cofunction of cosine and a complementary angle of also 45 degrees. So sine of 45 degrees in terms of its cofunction is cosine of 45 degrees. Let's go again. Tangent of 45 degrees in terms of its cofunction, well, tangent's cofunction is cotangent, and the angle complementary to 45 degrees is 45 degrees. Let's go again. Cosecant of 45 degrees in terms of its cofunction, well, cosecant's cofunction is secant, complementary angle to 45 is 45, so the value of cosecant of 45 in terms of its cofunction is secant of 45 degrees. You can confirm these values by using your calculator or the table. For example, here, let's look at this one. Sine of 45 degrees is equivalent to cosine of 45 degrees. So using the table, sine of 45 degrees is radical 2 over 2, and cosine of 45 degrees is also radical 2 over 2. Okay, let's do a few more. D, cosine of 50 degrees in terms of its cofunction, so it will need to be sine using the complementary angle of 50 degrees, which is 40 degrees. Cofunctions are paired up, complementary angles, and if you want to check this, you could go to your table, but this particular table only has quadrantal and special angle values, so you can use a calculator, or you can go online and find a table that has more than just the quadrantal and special angles. But using a calculator, make sure you're in degree mode, and then you can check it by cosine of 50, which we see is equivalent to approximately 0.64, and sine of its complementary angle is also approximately 0.64. All right, two more. Oops. E, tangent of 71 degrees in terms of its cofunction would be If you said cotangent of 19 degrees, you got it right. One more. Secant of 45 degrees. In terms of its cofunction would be what? If you said secant of 66 degrees, you got it right. Okay, in this example, we're asked to evaluate cosine of 780 degrees using a coterminal angle. So let's draw a sketch of a 780 degree angle. Terminal side opens in this direction. Now we're at 360, another full rotation. We're at 720. 60 more degrees will get us to the 780 degrees that we need. So here we have a 780 degree angle. To find its coterminal angle, we need to subtract out these full rotations of 360 degrees. So we take our 780 degrees less 2 full rotations of 360, giving us our coterminal angle measurement of 60 degrees. Okay, so if we have cosine of 780 degrees being equivalent to the value of cosine of 60 degrees, and we can find the value of cosine of 60 degrees using our table here, which is 1/2, then that value is also the value of cosine at 780 degrees. Quick note, it's a good habit to check the sign. With coterminal angles, they terminate in the same quadrant, so this shouldn't be an issue, but it's a good habit to always check. So the note here says 780 degrees is in the same quadrant as its coterminal angle, and therefore they have the same sign. All right, here's one for you to try. So please pause the video now and evaluate cotangent of negative 675 degrees using a coterminal angle. Welcome back. Let's see how you did. If you came up with 45 degrees as your coterminal angle, you got that right. If you then found the value of cotangent of 45 degrees to be 1, you got that right, and therefore the value of cotangent of negative 675 degrees is also 1. Nice work. Same note, negative 675 degrees is in the same quadrant as its coterminal angle, 45 degrees, and therefore they have the same sign. All right, our next definition is a reference angle. A reference angle is the positive acute angle made by the terminal side of the angle and the x-axis. A reference angle is written with this Greek symbol right here, and that notation that is read theta prime. Okay, that was a lot of terminology in that definition, so let's break it down a little bit. A reference angle is a positive acute angle. So let's make our theta prime needs to be positive and acute. So it needs to be strictly between 0 degrees and 90 degrees. Okay, continuing with our statement. Reference angle is a positive acute angle made by the terminal side of the angle and the x-axis. It's written as theta prime and read theta prime. All right, we have a visual for reference angles in each of the 4 quadrants. Let's start by exploring quadrant 1. If the terminal side of theta lies in quadrant 1, then theta and theta prime have the same value. I'm going to note that right here as we move on to quadrant 2. I think it'll make more sense as we go through all the 4 quadrants. Here we go. Should the terminal side of theta lie in quadrant 2, then theta prime can be found by using 180 degrees less the measure of angle theta. Let's explore the figure and see why that is. We can see here that the terminal side is in quadrant 2. That's the terminal side of theta. Theta prime is then created by that same terminal side and this side of the x-axis this time, giving us an acute positive angle measure noted as theta prime. This is the reference angle, and you can see that theta and theta prime are supplementary angles. So to find the value of theta prime, we can do 180 degrees less the measurement of theta. Let's go again. Quadrant 3. Should the terminal side of theta lie in quadrant 3, then you can find the value of theta prime by the value of theta minus 180 degrees. Let's explore the figure to see why that is. If the terminal side is here in quadrant 3, then theta prime is created by that terminal side and this part of the x-axis, giving us a positive acute angle noted as theta prime. So to come up with its measurement, we need to subtract out the 180 degrees created here, leaving us with our value of theta prime. One more, quadrant 4. Should the terminal side of theta lie in quadrant 4, then theta prime, its value can be calculated by taking 360 degrees and subtracting out however many degrees theta is. Using the figure to see why that is, theta prime here is created by this terminal side and this piece of the x-axis. That gives us that positive acute angle called the reference angle, noted as theta prime. And its measurement, as you can see, theta and theta prime together create one full rotation of 360 degrees. So if we take our 360 degrees and subtract out theta, it leaves us with just however many degrees theta prime is. Okay, in this example, we're asked to evaluate cosine of negative 240 degrees using what we just learned called a reference angle. Okay, we're going to break this down into a step-by-step process. Step 1, we're going to find the coterminal angle of our negative 240 degrees. Please note that if our angle was already between 0 and 360, we wouldn't need to find its coterminal angle. But negative 240 degrees is not between 0 and 360 degrees, which is why we are doing step number 1, find the coterminal angle if needed. So if we take our negative 240 degrees and add one full rotation to it, we find the coterminal angle to be 120 degrees. Step 2, we're going to find the reference angle, theta prime. Well, quadrant 2 is where we will find a 120 degree coterminal angle. And so from the last slide, we know that if the terminal side lies in quadrant 2, we can find the value of theta prime by taking 180 degrees less the value 120 degrees, giving us our reference angle, or theta prime, of 60 degrees. Step number 3, we're going to find the value of theta prime. We were asked to look at cosine. So cosine of 60 degrees, or cosine of theta prime, is equivalent to 1/2. We can see that from the table that we have to reference right here, function values of quadrantal and special angles. Cosine of 60 degrees is 1/2. Okay, last step. We need to check the sign. Remember I told you it was a good habit, so here we go using that same good habit. Depending on the quadrant, cosine of negative 240 degrees might be the positive 1/2, but it also might be the negative 1/2. So we are in quadrant 2, if you recall. And if you're using this clever all students take calculus way to remember the signs of your trig functions in the different quadrants, then you would go to quadrant 2, where the S for all students tells us that sine and cosecant are the only two trigonometric functions that are positive in quadrant 2. Therefore, cosine is negative in quadrant 2, making our exact value of cosine of negative 240 degrees the negative 1/2. All right, I want you to pause this video now and use that same 4-step process to evaluate tangent of 675 degrees using its reference angle. Welcome back. Let's see how you did. For step 1, if you came up with coterminal angle 315 degrees, you got it right. For step 2, if you came up with theta prime equals 45 degrees, you got it right. For step 3, the value of tangent of 45 degrees is equivalent to 1. You got that right? Now step 4, we need to check if our final answer is going to be +1 or -1, dependent on the quadrant. We are in quadrant 4, and tangent is negative there. Therefore, our exact value of tangent 675 degrees is -1. In this example, we're asked to evaluate cosine of 120 degrees plus twice sine squared of 60 degrees less tangent squared of 30 degrees. When our task is to evaluate an expression like this, I personally like to turn my expression into a blank template. It would look like this. Cosine of 120 degrees is going to have some value, so I put a blank there for it. Copying the complete expression from left to right, I have a plus sign, a 2. Sine of 60 degrees is going to be a value, which is why you see the second blank, and the squared goes on the outside of that blank. Let me take a moment to elaborate on that. It would have been nice if we could have written this as sine of 60 degrees squared to help us remember that that squared is squaring the entire value of sine of 60 degrees. However, if you see it written like this, you might notice that that could be a little confusing. There can be room for interpretation here. What exactly is being squared? Is it just the 60 degrees or is it the entire function value? Well, to avoid that confusion, we could add parentheses on here, showing that we are squaring the entire function value of sine of 60 degrees, but that notation would require 2 extra characters. And we know that this language is written with the least amount of characters possible. So instead of writing it like this, you will often see it written in least amount of characters like this, sine squared 60 degrees. So note that when you see sine squared of 60 degrees, you can rewrite it like this if you want to, or you can turn it into your blank template, remembering to put that squared on the outside of the blank. Moving on, we have the minus sign. Tangent of 30 degrees will take some value, which is why you see your third blank, and again the squared is on the outside. All right, let's fill in our 3 blanks now. Cosine of 120 degrees, using my table over here, is -1/2. Sine of 60 degrees, that value gets our second blank. It's radical 3/2. And tangent of 30 degrees, that value gets our third blank, which is radical 3/3. It looks like this. And we have technically done what they asked. We have evaluated that expression. However, this answer is not in its most simplified form. So everything we're going to do from here on out, it's not trigonometry, it's just simplifying the expression. Note your order of operations. First thing we're going to want to do is simplify anything we can inside of parentheses, which we can't. So we move to our exponents. So we're going to square the top and the bottom, numerator and denominator of the fraction inside parentheses. So our more simplified line looks like this. Make sure you're writing complete sentences left to right. So even though we've only squared these, we have rewritten the entire expression. Next, order of operations says to do multiplication. So we're going to do the 2 times the 3/4 here. Next line, in its more simplified form, yet complete, looks like this. And our last operations at hand are addition and subtraction. To do so, we need a common unit or common denominator. So we change all of our units or denominators into 36ths, and now we can add and or subtract as needed, getting us to 24/36, which reduces to 2/3. So remember, if your task at hand is to evaluate, you should be coming up with a value like this one here, the 2/3. So I want you to pause this video now and try one yourself. It is to evaluate sine squared of 225 degrees plus 2 cosine squared of 315 degrees. Welcome back. Let's see how you did. If you created a blank template, that's one strategy. It would look like this. Filling in those blanks would be the negative radical 2 and the positive radical 2. From there on out, just simplifying, our value takes us to this, followed by the multiplication of 2 and 2/4. And finally, the addition brings us to 6/4, which in its most simplified form is 3/2. All right, we're going to pause the video now and turn to our homework. Please do question numbers 1 through 16 in my lab in mastering. My name is Jamie Amy, and I will see you next time.